Да продължим на английски, така?
Да, на английски.
Добро. Thank you, and thank you everyone again for joining us today. As Peter already mentioned, I will be walking you through snapshot testing, some guide about it. And throughout this presentation, we will answer a few questions such as what is snapshot testing, how do these tests work under the hood, how you can add them to your project, and whether you should do this at all. Now, this is a fairly new thing, and I know it's not added to a lot of projects, so can the ones that have worked with snapshot testing raise their hands just so that I have like a rough number? If there's anyone. Okay, cool, so this will be interesting. This will be interesting for all of you. Don't worry, it's not like a very difficult thing, and I think that you'll learn a lot throughout the presentation. So let's answer the first one real quick. What is snapshot testing? Snapshot testing is a technique of checking your user interface by comparing its current state to a reference image. If you go and like look for a definition for this, you'll find a bunch of them which are mostly saying the same thing. The important part about snapshot testing is that it will tell you if there is an unwanted change in your user interface, but it will not tell you what this change is. So you'll have to look for it yourselves. It does not replace other forms of testing, but it's a great addition to them. It checks the UI, as I said, and I'll be mentioning the term UI quite a lot throughout the presentation. So I want to emphasize that snapshot tests and UI testing is not the same thing. Snapshot tests check how the user interface looks like across different setups and different devices, meaning screen sizes, whereas UI tests check if the correct user interface is displayed on screen. So to put that into perspective with an example, if you have, let's say, a label that shows a very long text and it's supposed to go in multiple rows, what snapshot testing will do is tell you how this multi-row text looks like on, let's say, an iPhone 11 and an iPhone 14. The UI testing will check if the correct text is displayed on the screen, if you have the right information. How do these tests work? The snapshot testing process takes place in 3 phases or 3 steps, which are quite simple. The first one is recording a reference image. This reference image, also known as a snapshot, is practically a capture or a screenshot of the user interface, and it has to be taken when you know that your UI looks the way it's supposed to, which is usually done at the beginning. It works. The next thing we can do is write them. In order to do this, we need to import the library that enables us to do this, which is the Swift snapshot testing library. And it's very easy to add it regardless of the package manager you're using on the project. So for example, if you're using SPM, you can add it as a package, of course. And the important thing to note here is that by default, packages are added to the project, so make sure you add it to the testing target as well after you add it to the project. And yeah, if you're using Cocoa pods, you can just add it to the pod as a pod in the target that you need. Before we get to the test cases and the test class itself, this is a very simple DOM view that we're going to use as a reference. So keep this in mind. As you can see, this view is pretty simple. Let's call it an alert view. And it will have, it has actually 3 setups. So the first one has an image, title, description, and a button. The second one is without a description. And the third one has 2 instead of 1 button. Now, in order to write the test cases, we need the test class, as I already mentioned, which, following best practices, has the name of the component that you're testing, appended with the keyword tests. It also needs to inherit from XC test case in order for you to be able to run the tests. And it can contain as many methods as you need to cover all of the setups that the view can be in. In our case, as I showed you in the slide before, we have 3. That's why we have 3 test cases, test methods here. We'll see how the implementation will look like in a second. The key part of all of these test cases will be the assert snapshot method. And this is the method that is used to perform the check in every test case. It's, of course, provided by the snapshotting library that I mentioned. And you'll find a bunch of versions because this is an overloaded method. So you can go for either one of them, but we'll stick to this one. They're pretty similar. They only have some parameters which are different. This one has two required parameters. The first one is a value, and judging by the type of it, it looks a tad more complicated than it actually is, because essentially what we're going to be providing here is just the view. And the second parameter that doesn't have a default value, meaning we have to provide one, is the snapshotting parameter. And here we will provide the strategy that we're going to be using for the testing. Sorry. So the strategy that we will focus on during this presentation is going to be the image strategy. The reason for this is because it's the easiest one and the one that has the least requirements of the view. Other strategies are, for example, JSON. You can also use JSON. That one's also quite good and quite good in the sense that you don't have to take care of a lot of stuff. You can simply just use it. There's also plist, which has requirements, and raw value, which also has requirements for the view to be able to use it. Now we finally get to the test cases, and let's say that the view that we previously looked at is written in Swift UI. So what you need to do in this case is first instantiate the view in the sense that you need it to be. Then you use the assert snapshot method where you provide the view that you're testing and the image strategy, and then you'll have to run the test. One important part here to note is the frame view modifier, which we use to set the size of the view. And the reason we do this is because if we don't, our capture, because you're getting a literal image, when you're using the image strategy, it will be off. It might not take your whole view into account. We'll see how that looks like in one of the following slides. The other view modifier is the background. This one is not mandatory, it's optional. And it's here more so to show you that if you need to modify the view in any way, you can definitely do that. Of course, don't go overboard with it because it's still a test, but if you need it, you can do it. Or any other modifier for that matter. If the view is in UIKit, it's pretty much the same thing. You will instantiate it. It will be a bit different, but as you can see, it's not too different. You still use the assert snapshot method, providing the view and the image strategy, and you run the test. But here the key part is that you will need to provide the size. Unlike Swift UI, the UIKit view needs to have a size. Now, the reason for this is if you don't provide it, you will get the thing on the left. It's your left, but yeah, you get it. You will not get a capture of your actual user interface. Instead, you will get an image that shows the error that your size, the view has a size 0 and you have to provide one. And on the right side, you can see the Swift UI view, the capture of the Swift UI view, and yeah, it looks hideous, but it's still captured. So in both cases, make sure to provide the frame or size parameter and solve this issue for yourselves. If you're testing a Viper view, and I'll explain why I'm using a Viper view here. It's kind of a loose definition. It doesn't have to be a Viper view. It just has to be a more complex view. Because previously what we were testing was a small fragment, a component, if you will, which is a smaller view, not too complicated, and the bigger complex views consist of 2 or more of these component views. Now, the differences in testing a more complex view is basically you have to add more dependencies, but you still instantiate it pretty much the same way. And the second difference is the snapshotting parameter of assert snapshot, which is basically providing layout. Now, to note here, as you can see, this layout, it's actually Swift UI layout, because this view is written, this Viper view, complex view, is written also in Swift UI. If it was in UIKit, you would be using size, just as I showed in the previous slide. We also use the named parameter here, and the reason for that is basically to differentiate between the screenshots that you will be getting. By default, they have the name of the test case, and then they have 1 or 2 or 3 or how many methods assert snapshot, how many times you're using the assert snapshot method inside of the test case. And I mean, in this example, we're only using 2, but we could have been checking for multiple. And we only have 1 test case because this is, even though I'm trying to explain it as a more complicated view, this view does not change based on the data that it gets. Of course, in some more complicated views, your view might look different based on the dependencies, so you would have to have multiple test cases as well. The big and small layout are custom layout configurations. Here, for example, we're using iPhone 13 Pro Max and iPhone SE to show smaller versus bigger screen. The less supported devices are the 13s. The 14s are technically covered by the 13s and the previous device sizes. For example, as far as I know, 13 Pro Max and 14 Plus, at least online, it says that they're the same size. I've never measured them. And yeah, the iPads are also covered. The 15s are not covered. The iPhones are not covered yet, but I'm assuming they'll also add them pretty soon because, yeah. Now we have everything set up, and let's pretend we covered all test cases, even though we only technically covered 1 setup. We run the tests, and we get a bunch of red, a bunch of errors. So what did we do wrong? We didn't do anything wrong. It's in the way that snapshot testing works. We never recorded a reference image. We never stored an image anywhere, and therefore we have nothing to compare our current user interface against. And that's exactly what this error says. No reference was found on disk. The way we can also do this, like the cool thing, first of all, with snapshot testing is that it will automatically do this for you in case you forget to provide this record parameter. That's the second part of the error, which says that a reference image was automatically created. We do want to explicitly do this, even though assert snapshot takes care of this the moment it fails to find a reference. And the reason for this is that we want to avoid mistakes on our end. So basically to be more explicit with our intent. And also this gives you the opportunity, if you want to rerun a test, to just rerun that test specifically or that test case. And as I mentioned, you get an actual image, as you can see here. It's a PNG file. Now, you have to remember to remove this record parameter because if you don't, your snapshot tests will keep failing. Now, based on what I just said, does anybody can think of why this might be? Why this might happen? Why do these tests keep failing? It's pretty logical if you think about it, but it might get like past your heads the first time. No one? Okay, so the reason this is happening is because the record parameter is true, is set to true, so a reference gets recorded every time. And you're not really performing the comparison at any moment. It just keeps generating a new one and a new one and a new one and replacing the old one, and you're not really checking anything. Yeah, you can remove it entirely because it defaults to false, or you can just set it to false and then bring it back to true whenever you need it. But yeah. Your tests might be failing later on as well by no mistake made on your part. One of the reasons for that is you're perhaps working in a hybrid team, meaning some of your teammates are using Apple Silicon and others are working on Intel machines. There are minor differences because of this, which may cause some or multiple of your tests to fail. Another reason is due to anti-aliasing, and one common reason that I personally experienced was if you're using, this is pretty logical as well once you've worked with it, but the first time it really gives you a headache. But if you're using one device to record the snapshots and then you're running the tests and checking them on a different device, they will fail, especially if there's a big difference between the sizes. If they're pretty similar, most of them will pass, if not all of them, but if they're too different, yeah, you'll be wondering what's happening. And this also happens if you're using one device for checking remotely on your CI where you're creating the builds, and another device locally. So you have to keep this in sync. So yeah, that way you get rid of the third cause. And the first and second one you can solve with two parameters, the precision and perceptual precision parameters, which can be provided to the image strategy. And these two parameters are the way that you can make your images not be 100% match, force them to not be checked in that way, and also, as I said, the reasons why you would want this. The precision parameter has a default value of 1, and that means 100%. If you want to, if you need them actually to be passing, for these tests that are failing to be passing because they're fundamentally matching, you can decrease this to 0.96 or 96%. Of course, don't just jump to 96%, go gradually and see where you will find the fine spot. But you can, if that's the reason. The perceptual precision also has a default value of 1 or 100%. And the difference between these two is that the perceptual precision, according to the documentation, is the percentage a pixel must match the source pixel to be considered a match. And it sounds so confusing when you read it like this, but what it actually means is, if, with the simplest words possible, if you as a human with your hopefully good eyesight or semi-good eyesight, either way, you can tell the difference between these two images, which most of the cases, and by default, the human eye can, the precision of the human eye is about 98, 99%, which is why you can decrease this to 0.98, 0.99. Now, a note on this is that if you find yourself decreasing the precision to 95 or even less than 95, you probably want to stop and reconsider. The reason for this is that you're going way too low and the comparison will not really make sense. It's okay to slightly tweak the precision. It's not okay to completely invalidate the purpose of doing the snapshot test in the first place. And if you're decreasing it so much, it might be due to some other reason, that some mistake that maybe you did on your part, and not some reason like the ones that I mentioned before. So now that we know how to write them, the real catch is to know whether we should use them at all. Because there are cases where snapshot tests will and can help you, and there are some cases where they will practically hinder the development process instead. If you have static views that don't change, or better said, views whose design won't change until not in the foreseeable future, then they're a great addition to your project. You will be able to get information out of them. Obviously, the opposite case is bad to use them if you have views that change a lot. And the reason for this is that worst case scenario, you will just have to re-record the snapshots. For example, you change the font. So you'll just re-record them and all's good. Worst case scenario, you'll have to rewrite the tests, re-record the snapshots, and then run them to have some kind of reference image, which means you would be essentially creating new tests. And you can get why it's bad in this case. By now, I think we're convinced that they're pretty easy to set up and write. They only take, I don't know, 5 to 10 minutes initially when you add them to the project. They can help you in noticing unwanted UI changes, and they're also great for this specific case if you're refactoring UIKit to SwiftUI components. You can use them the other way around, of course, but I don't see anyone doing that, refactoring UIKit to SwiftUI. It's usually the other way around. And the way you would use them here is you would create a reference image, a snapshot, with the view being in UIKit. You would refactor it and then check against the newly refactored SwiftUI view. Of course, you would have to create some kind of wrapper to be able to instantiate both of these the same way, both of the views the same way, but it's pretty easy to do, and yeah. it's probably the best case you would use these snapshot tests for. And consider them, but think about it if you're reluctant to using third-party dependencies, because after all, they're a library, another thing that you will need to add to your project. To sum all of this up, snapshot tests are easy to set up, very easy to write. They will tell you that there's something wrong with your UI if there was something that was changed, but should be used carefully and only in the situations where they will actually provide an information instead of being an obstacle to the project. And that's all. Thank you.
Hvala ti, Tamara, super, mislim, сите што никад не слушнале за тестинг, беше убаво интро и убаво објаснување.
Да пробаме ја да видиме дали ќе се шерна.
Требало веќе ти работи.
Да, се е окей. Да речеме, На английски почвам?
Да, на английски.
Окей.
Филип, пусти стримът.
Все окей? Yeah, unofficial hello from my side. Like Petar said, I'm Nico. I've been working at etc. for about 3 years now. And today we are going to talk about the Combine framework. Combine itself, by itself, is a really, really large topic, but today I'm gonna try to cover up the basics and hopefully everything will work since it's not on my laptop. Let's see, but yeah. Going on to the intro, so today's presentation is gonna be more practical, so I'm gonna dive into coding like a few slides in. So before everything, let's clarify what is Combine. Like the first sentence you see here is copy-paste from the Apple documentation site. It says that the Combine framework, it provides a declarative Swift API for processing values over time. These values can be represented many kinds of asynchronous events. This couldn't be more correct by itself, but if you ask me, like, if I read this sentence before even starting to use Combine, I would have no idea what it says, but it might just be me only. So if you ask me, I would say Combine is everything regarding asynchronous data streams. So you have this stream, which publishes values over time, doesn't matter when. The whole point is it doesn't happen synchronously. Everything is asynchronous, so Combine gives us a nice API to work around kind of all this stuff. So those 3 bullet points is how I would summarize Combine. So it says first, it helps with asynchronous events, like I said. The whole point is regarding data streams that can happen over time, and they can happen anytime. So you would have this nice API handling the threads when you receive these events and all that stuff. I mean, of course, everything can be done without Combine, but Combine offers such a nice API, why not to use it? Then the next thing is helps with building data sources that can change over time. Again, coming back to my original set, data streams that can happen over time. Like I said, the whole point is reacting upon changes on some data source. So Combine gives you a great API. It's very nice to use it in that case, so I'm gonna show exactly how to use that. And the last topic is helps creating data streams when a certain piece of data needs to have a lot of pre-processing before using it. You have this data stream, you wanna do something with the data, you wanna map it to another model, you wanna filter it, you wanna do all this stuff with that, and Combine gives you this nice reactive programming style in which you have operator, dot operator, dot operator, and it kind of wraps this up in a nice, clean way to do that. So before going into any practical work, it's important to be clear of the basic entities that are in Combine. So you have the publishers. The publishers are the starting point in any data stream. So the publishers are the one who will actually emit the values you're interested in. So anytime you create a publisher, you have the output type and the failure type. The output type is actually the type of the data that the publisher will publish or will emit. That publisher, according to you, can either fail or can either not fail. So you will do that by the failure type. So you can specify if the publisher fails, you can specify what kind of type of error the publisher will emit. Or if the publisher never fails, you can say just there's this type called never, and you can say that this publisher will never fail. On the other hand, on the other end side, you will be the one that listening to the publisher. You would be the subscriber. You would use some subscriber to listen to those values. The subscriber helps you create a connection with the publisher. So, and anything in video. So of course, if you're on the other hand, you would not have an output type. You will only have the input type that the publisher emits, and the failure type that the publisher emits as well. Anything in between, like I said previously, the publisher will allow you, the Combine framework will allow you to use this kind of reactive programming well. So you have a method, data method, data method, data method, and so on. All those methods are called operators, so that can be attached to some publisher and then can return a publisher. So whatever the publisher is an output type, the operator would be the input type, and so on. The operator are not a mandatory thing. But yeah, they can be used. So if we have an overview of the publishers, they can be a one-shot publisher, meaning this publisher only shot one value and will reach its completion. We have some out of the box, like the future. The future can be, I don't know if I have an example today with the future, but the purpose of the future is for you to map some kind of asynchronous way you already have with completion handlers and all that stuff into a publisher way. Like I said, I'm not sure. I think I didn't put an example with the future publisher, but yeah. The whole point of the future just and failure publisher is that they will meet one value and they reach each completion. So the publisher, there's this term that they will reach its completion, meaning that they will stop emitting values. You have the continuous one. This could emit for a long period of time, unless someone stops them and all that stuff. We have three here. We have the current value subject, the pass-through subject, the add publish property. On this, we're gonna have a special focus today. These are the very last. These are the ones actually I find most value using from. I'm gonna show how exactly. We have the limited publishers. Again, this is just a nice wrapper around some existing stuff we have with Swift, like the force cycles and all that stuff. You have some sequence, some array. You can build a publisher out of them, out of the box offered by Apple. For that, I for sure have an example. You're gonna see them. And then you have the foundation publisher. This is the usual stuff you would use from the foundation framework, and there's a publisher version used out of them. For the timer, for sure I'm gonna show an example. For the URL data task, I'm not sure, I think I didn't put it in someone, but yeah. Let's see. Like I said, the publisher, all you need to keep in mind is that the publisher are starting the whole flow. They are the one emitting the values. You can subscribe to them. And afterwards, it's the stuff you're interested on. So then we have the subscriber. That's the very end. So in combine, you have the one emitting the value, and you have the one who are actually trying to listen to the value. We have 3 subscribers to do that, so you can attach on the publisher using these 3 subscribers, the sync, the assign to on, and the assign to. These are the ones you would use to create a subscription, and then we come to the 4th term. The subscription, there's a basic difference between using subscribers and using subscription. The subscribers are the entity, let's say the classes that you use to attach to a publisher. Every connection you make to a publisher, it's called a subscription. So the contract between the subscriber and the publisher is called a subscription. I mean, you can use sync many times. Every time you use sync, the sync subscriber, you create one subscription using the sync subscriber. So that's the fundamental difference. And the operators, we're gonna see some throughout the presentation. They're not the main topic that I wanna focus on today, are just something modifying the publisher you attach on and giving another publisher along the way. It all starts using the subscription, so now I'm gonna sit down because I'm gonna start coding. Like I said, how you can create the subscription is the connection between the publisher and the subscriber itself. So we have 3 subscribers that we can use to do this. We have the sync subscriber, the assigned to on subscriber, and the assigned to. I'm gonna show an example with each and every one of them. We have some basic code to do this. I hope everything works now because my code snippets are not working here. So yeah, I'm gonna try to improvise now. Let's hope everything works. So, like I said, we have many publishers out of the box. We can use the sequence publisher. I'm gonna show that one as well. So we can create a publisher here. I'm gonna emit the values.
If you need a reminder.
Let's see. For now, I can come up with something. Shift, it works. So with this one, we have a sequence between the values from 0 and 10. And normally I would loop through them with a for cycle, but like I said, for now, I'm gonna use the publisher in terms, you can see it. So with dot, you can see there's the publisher right away. If I go, let's hope everything works. You can see, like I said, it's a sequence publisher. Those are the limited publishers we have in the combined framework. They emit values, and now I'll try to make a subscription user distinct subscriber. You can do this by, so let's see, publisher dot, and there should be sync right away. So you have two sync methods. The first one is the receive value. The second one is receive completion receive value. Normally you would use the second one. The second one also gives you an access when this publisher is done with emitting values. Since this is a limited publisher, this will for sure be done with emitting values in quite a few seconds. So let's use that. So we would receive a completion here, and oh my God. So I would print here the completion. Okay. And then here the receive value is actually every value you receive will be received in this completion itself. So I would name this as value, and I would print the value itself, received value. So I'm gonna run this stuff. So like I said, you have this publisher. On this publisher, we could subscribe to from any point actually. Let's see if this actually works. Hopefully it would. I don't see any result. That. It's still building. Yeah. Okay, fingers crossed that everything will work. So I could try and fill you up with some information while that is done. So the basic thing we want to show now is how you can keep a subscription alive over time. The lifetime of a subscription is until we hold a reference to it. So you would store it somewhere. I wanted to show that, but
Can you run it again?
Let's see. Running. Okay, there it is. This happens really fast, so you don't see any much, but the thing is, this happens one after another. We receive the 0 value, we receive the 1 value, and when this limited publisher is done with publishing values, we would reach the completion closure. The important thing is here, the life cycle of the subscription. The subscription would live, like I said, as long as you hold a reference to it. You can hold in several ways a reference to it. Here we're gonna do it with one, several. There's basically two ways. If you have multiple subscriptions, you can build a set out of subscription, then hold them in a set. If there's only one subscription, you can build one property and then store it in that property. So I'm gonna do it like that. Would have this var subscription. And one thing, what type the subscription is. So the Apple system wants to ensure that this subscription would be able to stop over time, so it does not hold the memories and all that stuff. So the subscription needs to conform to the protocol of any cancelable, meaning that it guarantees that this subscription could be canceled at any time. Meaning, this subscription is of type any cancelable. I keep missing the enter button, but now I'm gonna store it in the subscription itself. Subscription. So this by itself doesn't do any change to everything that I showed until now, but when does it make changes is when we want to stop this publisher. So if I try to stop this after a certain amount of time, let's see, dot main dot async after dot now plus 3 seconds, and I'm gonna try to execute some code. When this happens, I'm gonna try to actually stop this subscription. So I'm gonna say subscription dot cancel. So I expect, hopefully, everything works, and let's hope that the publisher doesn't end under 3 seconds. Otherwise, I would demonstrate this with a totally another publisher, because this is the one happening really quick. Okay, I can, because this is a limited publisher and it resolves it in milliseconds of time. I'm gonna show this with the timer one, but before showing that, so I see here that I have that section of showing the how to stop a data stream. I'm gonna try to cover up the other two. So like I said, you can create subscription with one of these 3 things. So the dot sync, the dot assign to on, and the dot assign to. So now I need to remind myself what was the example that I would have shown here. Assign to on subscription. Okay, so this is actually the example from the Apple side. So we would have one class here. Let's call it my class. I'm gonna try to do this. Oh my God. Quickly, let's see how quick enough. Var an int. So this would be an int value equals 0. And I would have a did set here. And every time we set it, we're gonna print one value. An int. Okay, I'm gonna just print the value here itself. So it's. So we have this class. I'm gonna build an object from this class. So we have our object, my class, and a publisher. So I would create another sequence publisher from the values 1 to 2. There's not parentheses, 1 to 2, and I would create a subscription afterwards. So again, I'm gonna use the publisher version we have out of those, and I'm gonna create a subscription here. So we have the publisher dot sync. Now I'm gonna use only this completion handler, and then so the whole point was using it not dot sync but the other one. So the whole point of using the assign to on is actually you have this object and you wanna assign it to specific values. I mean, in practice so far I haven't found a use of it. I'm gonna show you how to do it. There's a drawback of using this, but the whole point of using this is you have this object, so you wanna assign it to some object. In this case, the my class object. So if we use the object one, and there's the key path. The key path is to any property inside the class. So in this case, you have the an int, and if I try to assign it to that value, hopefully everything works. We should invalid redeclaration. Okay, so I need to delete this code so it doesn't mess up my. Okay, everything seems to be building, and when I try to start using it, you would see that in the dit set we print three values, the 0, .1, and .2. At first glance, there's not a problem using this. The thing is, the assign to on creates a strong reference to the object. So I think if I try writing now a view model and the D init overriding, and I'm gonna lose like 10 minutes. I had one example, but the whole point of this is the assign to on creates a strong reference to the object you try to assign the value on. So if you have a view model, if you have some class and you want to be able to deallocate that, you should not try and using this assign to on because it's gonna create a memory leak. However, there's the third one that actually resolve this issue. So I'm gonna try to come up with an example of that. So that's the assign to. If I create now one class, which is, let's say, our view model for some view. So I keep missing the shift button. And then we have this add published values. So this is one of the publishers which I was going to cover today. Let's see how that turns out. But the thing is, this is one of the publishers that the Combine framework offers you. This builds a publisher out of every property. So if I now declare an int here, again, one int, I would call it ID here, user ID, and set it up to 0. You can subscribe to this publisher and listen to changes of this property itself. The thing is, what I wanted to show now, if I make one init method here, and let's try to create one struct, my model, and this one would have ID, int. The thing is, let's say we have this publisher. Now I'm gonna use, again, another publisher that I haven't mentioned by now. That's the current value subject. This is one of the continuous value publishers. So you can publish values to this publisher over time. It's not limited like the sequence one. We have the values from 0 to 10, and after it finishes, this one never finishes until you explicitly set to finish that. So I'm currently going to publish values out of my model. And like I said, every publisher has this output type. That's the type of values that the publisher meets. And then you have the failure type. If there is a possibility for this publisher to emit an error, you will need to specify the type of the error here. So for demonstrating period, I'm gonna set that this will never happen. And the thing is, with this publisher, you need to give some initial value. So because we give to the published one 0, I'm gonna give this one 0. So the whole point of the example is every time we receive new value to my current value subject, I want to assign that value to the add published publisher. And we can do that with the third subscriber I showed here, the assign to. Also, I haven't done some practical work with this one, but just for the references of int. So again, I'm gonna try to assign that to what, and here you need to pass the publisher itself. You cannot just pass user ID here because user ID by itself is an int property. You will need to pass actually the publisher here. So you can, for the add published properties, you can access the publisher by the $sign. So this should, okay. The thing is the current value subject emits my model type of values, and here the add published property receives an int type of values, so you will need to map this here. So here is the first usage of an operator This one is attached to a publisher and returns the publisher down the stream. So I would use the key path version here, meaning that I would map just to the ID itself. So I would take only the ID and I'm gonna send it down the stream. So with this here, I would say this is much more useful than the previous one. First, it doesn't create a memory leak here, so you're safe on that side. And again, this is much more useful if you have a state property or something like that and you wanna emit it down the way. This should work. Should is the keyword. So I'm gonna try to actually create. So let's I signed it as view model, and then I'm going to sync view model the public one VM dot. So like I said, with the $sign you access the publisher itself, and then if you do sync user ID print, I can just say user ID here as well. So if I run this code by itself now, nothing will happen. No one ever, okay, something happened. It says unterminated.
Delete line 47.
Hmm?
Line 47, delete.
There is, which line? There's this comment, this one. But that's the starting point of this comment.
Can you scroll up?
So it emitted one value. I guess I pressed play at the wrong place. So the thing is, this by itself, of course, we have a current value subject. It has initial value. You subscribe to it, it emits the initial value. What happens over time is how we can make use of it actually. If I try to send some value down this current value subject, there's this send method. I can send some different model, let's say with 445. And now, hopefully, fingers crossed, you would see this. So yeah, there it is. Yeah, the whole point of this example is how to use the assign to subscriber. Like I said, in my personal work experience, I have never used the assign to on. I have never used the assign to. I only use the .sync publisher, and I'm gonna use that one towards all the examples that I would probably come up during the presentation. But yeah, just so there's a reference what can happen using those. Like I said, there's a whole topic of how long this subscription actually lives while we're using it in the app. Like I said, every subscription conforms to the any cancelable protocol, meaning that you could cancel the subscription using the .cancel method. If I go now to the, okay, I have deleted my code, so I'm gonna create another subscription here. I'm gonna store it in a property. Like I said, every subscription is of type any cancelable. And if I go now from the type, like I said, it's any cancelable, you would have this method .cancel. With this, if I try to now code, again, this is a current value subject. I'm not going to be able to demonstrate. I had an example prepared with some different publisher, but the thing is, this will stop listening to the values from the publisher subscribed on, one of the ways at least. Then some of the other ways is, like I said, you need to have a strong reference to it to be able to keep it alive. If you don't want to create a memory leak there, you can create this nullable, an optional. Of course, this now requires an question mark here because it's an optional. But since the property itself you're storing it in is an optional, so a weak variable, you can just deallocate it by saying this would be .nil. So this would as well stop listening to the values from that publisher. So this covers, this covers these two examples. The third one is when this publisher would actually resolves or terminates with emitting values is when it would start emitting an error. So the first time that an error emits, the publisher will stop emitting values and you will reach this, how to say, okay, I'm gonna try to do the other one, receive completion. So you will reach this completion closure because an error will be occurred. If I try to, of course, you can do something with this error, it's not just a simple value. If I switch this completion, you can see that it's the dot finish value and dot failure value. And with the let failure, you actually get access to the error that occurred while emitting values. So this will for sure stop the publisher from emitting values by itself. And then the last point is, like I said, as long as you hold a strong reference, so if this is a continuous publisher, meaning that it will be alive for a long period of time, while you're holding a reference to it in a property, in a set, or whatever. I didn't show the set way, so I can show that so you know what I'm talking about. Command Z. So we have a compiled code. Like I said, there's a set way. If the class you're subscribing on has multiple publishers, you can store them instead of creating a separate property for all the subscriptions. You can actually store them in one set of subscription and holding a reference to it. So that can be done while if we code these subscriptions and we create here a set of any cancelable, and there's this operator that it's offered by you by the combined framework, this dot store in, and you can just specify here the set of subscriptions you want to store it in. So cannot find subscription. I need to delete that one because that's no more valid, and I would delete this one. But yeah, so the whole point is of this part is that the subscription stays alive until you hold a reference to it. Either if you explicitly deallocate it with equals nil, you explicitly cancel it with dot cancel, although I haven't done this in a while. Usually when you subscribe to something, you want to listen to it over time, and you just wait until it fails. And you would hold a reference to it in your class. So this is how you can actually attach to a publisher, start listening values to it, and making use of the publisher itself. Next thing itself is, like I said, the publisher is a data stream. So the publisher emits values over time that happens asynchronously. And the combined framework by itself offers a nice API how you can do this. I mean, how you can control the threads by itself. There's this dot receive on operator, which I want to point out, which would be very useful in your everyday job. I will again create the simplest publisher there can be, dot publisher, and I'm gonna try to dot sync value. So again, this is a really, I don't actually need the parenthesis. What I wanted to point out here is here you have the ability on which thread you wanna receive the values on, meaning if this is a state property, if this is something that will update the UI, you would want to do this on, you would want to receive the values on the main thread and then update the UI accordingly. Easily that can be done by using the dot receive on. So with this part here, you can actually control where you receive the values on. This can be done by saying dispatch queue dot main, And this ensures that all the values emitted on this publisher will be received on the main thread. And after that, if you update some UI element or anything with that value, you're safe to do that. Of course, there's this one subscribe on, which I only will mention because in my experience, it doesn't always works as the documentation says it would work. So the whole point is the receive on controls the thread from the point of the receive on downstream. The subscribers should suppose control the thread from that operator upstream. So meaning on which thread you would subscribe this. So on which thread the publisher would emit the values. But this never worked once since I used it. I would say in my experience that on which thread the values will be emitted is in control of the publisher itself. So if you build a publisher, if you build a custom publisher, or you use some other publisher, he is the one controlling the thread. This has never worked once. If someone has experience with this, I would glad to hear it, but just to point it out as an operator there, the receive on always works, and that's the one I use every day. Because in my everyday work, we use publishers for the state of the view. So we listen to the state and we update the view itself. Just something that I wanted to point on. Moving on to the subjects. So here I had quite some rich examples. Let's put it like that. I'm gonna try to cover up them. The whole point of my today's talk is where you would actually, or where I actually found a lot of value using publisher, is building continuous streams over time. Like I said, the current value subjects holds, it's a continuous publisher, meaning that it emits values over time. I can build a publisher, so let's start publisher. So I'm gonna add here a current value subject, and it's gonna hold an int. It will never fail. Today we're not focusing on errors. And it requires an initial value. Missing argument, of course. So I'm gonna pass a 0. Usually how I use this subject in my everyday work is this actually holds the current state of the data source. The whole point of this publisher, every minute you can actually access the current state of the publisher. So even though you listened to the state previously, you can actually access the one that is current, that it's less updated. So if with the dot value, actually, you would print 0 without even subscribing to the publisher. Let's say publisher dot value. Okay. There's a 0. So this is from the previous examples. If I delete it here and run it again, this should actually only print 0. I'm gonna show a very useful scenario of this in a minute. Thanks God I didn't put a code snippet for that, so we have the code available for that one. But yeah, I'm not gonna focus too much now on because I have available example from this one, and you'll see it in a second. The next one that I'm gonna show is a pastry subject. In my everyday work, I didn't find use of it still. The only difference between the pastry subject and the current value subject is if I build it here, publisher tomb, and if I build now a pastry subject here, again, you will need to specify the output value of the subject and the error value. So here I'm gonna build an int again. So I compare it to my previous one, and I'm gonna put never here. This one doesn't require you to set an initial value. So if you read the Apple documentation here, it would say that you would use this one for triggering some actions or something. You would send like trigger, I don't know, logging or something like that. I have never used it. I have never found any useful usage of this. So just to be out there, I'm gonna show, there's a different, of course, since this one does not hold a value, you cannot do this like we did with the previous publishers. So there's no value thingy here, like we have with the previous one. The other part that I talk about, the subscription, the dot sync that stays the same for every publisher. You're gonna see it in the next example just for saving up time. Something that I wanted to put some explicit attention on is the add published. I've used it several times. For this one, actually, I'm gonna try and build some example. So again, I'm gonna create one mock view model here, and let's build, okay, it doesn't autocomplete. I'm gonna build the add published thingy. If I have the, I'm gonna actually copy paste this so we save up time. We have the add published and all that stuff. The thing is that I want to actually show you now is I need to build the sync value, new value, print, new value, received, and there's the new value, and there is the current value, which is in the property itself, user ID, and I need to store this in some subscription property, by subscription. I'm gonna do it like any cancelable, and I'm gonna do subscription here. So this is everything that I talked about since now. Why are you complaining? I'm gonna put self dot here, and let's see this in action. Let VM is view model, and I'm gonna actually use the current value subjects. I'm gonna send value upon all the over time. So send, I'm gonna send my model with value 455. Then I'm gonna send another value 456, and let's put one more for demonstration purposes. My model 457. Let's see if this works. Okay, I haven't done. I wanted to assign the value here. So I'm gonna set self.user_id equals new value. So actually the thing we did before. Okay, that works. Yeah, now that we have a working example, going to the theory part, we have the add published publisher. So the whole point of this is you have an integer, you want to build or whatever kind of data type, you want to build a publisher out of it. This will help you build a publisher out of the box. It will always set the failure type to never. In the background is a current value subject, so the one publisher that I showed several examples ago. And the thing is that you need to remember is it always publishes the values in the will set block of the property, meaning it would first publish the values and then it would store it in the variable itself. So here, don't mind this. This is just the first subscribe. Now, when I update, in every line, the new value is 455, but the current value is still 0. So if I build it right, actually, of course, this would be like this. But keep in mind that this will first publishes the value, and then it would actually show that one. So for me to show this one, actually, I would need to do this one. I just saw that I built the wrong example. So if I use the user ID, like I said, we built a publisher out of it, and I use the sync on that one, and here we have the value. We have the new value by itself, and then the user ID. I think, or is it okay? I never actually updated it, right? Okay. How to actually demonstrate this since I don't have the example. It published.
If it's too big, you can maybe send it to the chat in Slack later. Ако е много голям, може да го пратиш може да на Slack после.
Да, ама чекай, ако нещо ситно пропущам, да го... So I have usernames. Okay. So it's really simple. We have that. So this one doesn't matter at all in my example here. Let's do it like this. I'm gonna try vm dot user ID. So keep in mind here, I'm not accessing the publisher of the property, I'm accessing the property itself, and I'm gonna upgrade it to 455. Let's do this 3 times in a row. 456, 457. So, yeah, actually this demonstrates the thing that I wanted to show. You can see every time we update the value, so again, don't mind the first new value just because it has an initial value, you would have the first receive value, but every time we try to update it, so the first time we updated with 455, and first the new value we receive in the print statement here is the 455, but the current value itself is the 0, so the one before. So keep this in mind. Sometimes it made problems to me, mostly because we were using it with view controllers, so we keep the state still with @publish. This works perfectly with SwiftUI. I'm gonna show exactly why, but keep this in mind because, yeah, it has made problems to me in my personal work. Then, I'm gonna quickly touch upon the observable object property. It's not exactly a publisher, but it's something that does with publishers. So, if you have worked with SwiftUI views, and you would actually declare your view model with an observable object, and you will notice that you would have this @publish properties in the view, and the view will re-render itself every time one of those @publish properties will change its values. So how it does know that? So if I go deeper now in the VM dot, there's this object will change. So there's one publisher out of the box that with the observable object protocol you receive. So the SwiftUI views in the background subscribe to this publisher, and whenever this publisher fires values, meaning that any of its @published values emit a new state, it re-renders the view. Of course, I would have better example, but yeah, just an FYI. And thank God, like I said, for this I didn't choose to use code snippets. For this I actually have available example. This is I would say, the place where I found most use of Combine in my everyday work. So we needed this concept of having a responsive repositories, meaning we would wanna react. So we have these repositories, these data sources in which we keep values over time, and we would wanna react upon if that repository changes. So if we have a new value, if we remove a value or anything of its kind. We developed this concept using Combine. So we would keep a publisher out of the values in this repository, and you would subscribe to that. So in a view, if it's something you want to use, and every time you receive new value, you update everything you need accordingly. So this is a small example, meaning we have this mock data source. We have, of course, in code, we use either user defaults or some other storage you have on the go. Here I use the simple array just for the demonstration purposes. And we built a publisher, which actually publishes the values out of this array. for the beginning, we have empty values in both of them. And let's say you listen to these values in several views. So you have the view one, it subscribes to this data source, it observes the values and all that stuff. And if I just hit here play, again, this takes into account the previous values. If I just hit play here, you can see that right away, each of the views actually receive this value. It doesn't reach its completion because it's a continuous value publisher, it's a current value subject, it doesn't reach its completion by default. And if I, let's say, some entity, some service, something happens in the app that updates this data source. So like I said, the data source.add, I'm gonna try to add 3 values to the storage. All the subscriptions that have made will receive these values and they can react upon the changes they have there. So you can see that everyone first received an array with only 1, then an array with only 2, that 1 and 2, and then an array with 1, 2, and 3. This by itself solved our issue to react upon changes. So here again, if this is a subscription in a view, you would consider adding the .receiveOn operator I just showed previously. The thing I wanted to mention here and point out is you can see I added this mark to do .anyPublisher. So this by itself doesn't bring you any value. I mean, if it's a simple publisher like this, it's only a current value subject. But if you add multiple operators, the type of the publisher itself gets like really expanded, like really expanded. With any publisher, you just erase the type and you just say, okay, this will be a type of any publisher. The one using it doesn't care actually how you build the publisher up, so it doesn't care if it's a current value subject, it's any publisher. And all he can do is just sync to the values. Of course, this also brings, let's say, a secure point of view benefits. I said it in parentheses because it's not that really secure, but the thing is, if you're building, let's say, an SDK, and the one using your data source, you don't want to give them a lot of control of the data source, because now, if, let's say, this is some library that we offer, and we offer this .observe method, me, as an user of this library, can just say here, just data source dot send. Okay, I didn't make it public. Okay, so data source dot observe, that would give me an access to the publisher itself. And if I try now, I can actually send a completion here. So actually I could say this publisher will finish for all the subscriptions out there. So if someone else is using the library itself, you would stop the emitting of the values. So this is not something you would want to offer from your code. Of course, that can be, let's say, we can make this better. So if I create here, just for a comparison, if we use if we use any publisher. So how you can do this is just erase to any publisher. This will do all the conversion between the publisher, but it would give you, so I'm gonna put here .2. But it would keep you safe from anyone controlling the stream that you're offering. So now, if I try here .2, there would be this error. There would be like, you cannot stop. And there is no send function for a type any publisher. So you would only be able to subscribe to it. So you can see this code up here didn't fail at all. So like I said, this would offer you some type of security, but this is actually the use case I'm extensively using Combine for. We have many repositories that we want to react upon the changes that happen on that repository, and this is the way we do it currently. Of course, with using that one, I'm not going to be able to actually show this. At least I wasn't able on my computer, so I'm only going to go through the code because it gave me some warnings about the iOS value of the iOS system of the playground. But there was, once we started using Combine, there was this thing, okay, how are we going to write tests for the data storage? And of course, combined by itself, it's an asynchronous code. So you have these closures. There's the sync closure. And how would you write tests normally is you would have this expectation thingy, and you would wait for the expectation, all that stuff. And it's not the nicest. I spent a lot of time, so spoiler alert, I'm not saying this is the best way to write tests for combined, but this is the way I'm currently using for, and I found it very clear. So I use the new async await not technology, but the async await functionality that Apple offers nowadays. So it gives you a way to build asynchronous code, but coded synchronously. So I was like, okay, how can I write in my test, like wait for the next state, and once I receive it, assert it right away. So I found this way. Actually, there's this thing called async stream. You can build an async stream, and it's really easy to map the publisher to an async stream itself. So you can see here I'm creating a subscription. There's this event. This operator didn't show it previously, but there's this handle events. You can actually react upon everything that happens on the publisher itself. So every time one subscribes to the publisher or does something else, there are, I think, 4 completion handlers: receive, cancel, receive subscription. I can think of the 2 ones right away. But the one important for my test, if this subscription cancels, so I want to finish also the async await continuation I use. So that's why I have the handle events operator here. This is the one that I actually talk about ever since. So again, I finished the continuation when I receive the .finish completion. So if this publisher actually finishes in some time, I say, okay, continuation dot finish. But this is the important part. Every time I receive a new value, I say, okay, continuation dot yield with this value, and whoever is waiting for the next value with the await keyword will actually receive this value. This is how I build the async stream. So how I actually wait to those values is you have this iterator protocol. That's the one, you must have heard of it. That's the one underneath the for loop thingy. So you can build an iterator, and there's this .next function, with which you await every next element. And I just offer from this publisher observer, like I offer one method, next. I'll wait for the next values. This is, of course, a generic method, so it depends on the type of the value that the publisher meets. And how would your test look like? It's actually, you would build a state observer, and you would actually send the publisher here. I'm not gonna try to even resolve the error here, because I think we would lose a very long time. And actually, you would just say in your test state await .next value. And once of course, you will need to mark your test with the async keyword, but in my opinion, that's not a big deal. It's better than setting an expectation with a timeout and taking care of that. So you would actually say that this test could happen synchronously. I think there's a configuration for you to set like a global timeout for all the tests, so that can save you there. But you could actually mark the test as async, and I'll wait for every next values. And of course, if you configure the tests with a timeout of 5, if we don't receive an await value for 5 seconds, it would fail. But if this fails, it's most probably the way you build the publisher. There's a mistake there. At least in my case, this is the most clean way to write tests. Like I said, I cannot actually demonstrate this thing in a playground, but I thought it's really useful to show it just because it saved me up so much, and it helped me write clean code as well. But yeah, I hope with all the technical difficulties, you find it useful, everything I said today. And yeah, like I said, these are only the basic. There is so much you can do with Combine. You can imagine, but yeah, this is actually the one use case I extensively use it for every day. And yeah, that's all.
Дечки, дали има некои прашања? Петър, ти се възбуди за тестовете, айде.
Аз им тестовете.
Aha.
Слушам, изтрчам от коина.